Good morning. Today I'm going to be going over this tides and eclipses lecture with you. So I'm going to give you some basics on both of these topics in astronomy. And the first thing we're talking about are tides. So when we look at the Earth and the Moon, they both have a gravity that can pull on the other. So it's important to remember that any object has its own gravity. If it's a small object, the gravity is so weak you'd never be able to tell. But things like planets and stars and galaxies, they have their own gravity and they can exert that force on other objects. Let's see here. Now, what that means is the moon is pulling on the Earth and all parts of the Earth. Now, if it's pulling on the rock, it's not really doing anything to the rock. It doesn't change the shape of the rock, but it can pull on the oceans, the waters of the Earth. And it's strong enough to affect these waters. So we see this particularly in the ocean. And the direction of this force is going right towards the center of the moon. So down here, what we see is the Earth without any of the continents or anything. And it's just showing you since the force is directed right at the moon, the water and oceans that are up here on the top and the bottom will get forced down towards the equator. And so this force kind of builds up and builds up this way. Well, that's going to create a bulge. And that bulge is going to be on both sides of the Earth. So you're going to get a bulge on the side that is closest to the moon, and you're going to get a bulge on the side that's opposite of the moon. And you can see that in this image. There's a bulge over here and a bulge over here, even though the moon would be out over this direction. The thinning comes at both the North and South Pole. And what happens is this bulge is always pointing towards the moon, and the Earth is rotating through that bulge. Because in one day, in 24 hours, the Earth makes a complete rotation around its axis. But the moon has hardly moved in that one day. It hasn't moved that far. So this bulge just points that way, and Earth spins through that bulge. All right, let's look now at eclipses. So there's two types of eclipses. The first one, and the one that people have most likely heard of, are solar eclipses. And you see the solar eclipse in this image here. That is when the moon blocks the sunlight coming from the sun, right? And this, by blocking it, it creates a shadow. Just like if you were standing in the sun's light and you create a shadow of yourself on the ground, the moon is creating a shadow on the Earth. But look at how big that shadow is on the Earth. It's actually very small. The shadow doesn't extend over the whole Earth, just a very small portion. And as the Earth rotates, it's going to create a line of shadow across the Earth. That is a solar eclipse. But there's also lunar eclipses. Lunar eclipses have a different setup. What you see in the picture is in the lunar eclipse, you have Earth blocking the sun's light. So it's between the moon and the sun. Sunlight. And it creates a shadow on the moon. The Earth creates the shadow on the moon. How does that shadow compare to the solar eclipse? what you'll notice is the shadow from the Earth on the moon is much bigger. It can completely cover the whole moon, eclipsing the whole moon, where the shadow that the moon created up here was very small. Okay, now let's look at the specific types of solar and lunar eclipses. So up here, we have 3 types of solar. There is the total solar eclipse. And in a total solar eclipse, what we see in this image is the sun is completely covered. There's no parts of the surface of the sun showing once the moon has passed in front of it. The next type, which you see in this middle picture, is called an annular eclipse. Sometimes they call it a ring eclipse because you see a ring of the sun's surface as the moon passes in front. So there's this ring of the sun's surface that is still visible. And then the last one is a partial solar eclipse. And what happens with a partial is only a portion of the sun is covered, and it never goes complete. So in a partial, you have the moon slide past the sun, but only a small amount. It doesn't go completely over. Partials can be seen from more areas of the world than the total eclipse can. Now, what about the lunar eclipses? So lunar eclipses, the first 2 phases first 2 types look pretty similar to the solar eclipses that we saw up here. In the lunar eclipse, the first 2 are called the same thing. There's a total lunar eclipse, and there is a partial lunar eclipse. And you can see these images that they look similar to the solar eclipses, but one small difference. In a total lunar eclipse, the moon doesn't get completely blacked out. It actually takes on this deep red appearance. And that's because there's still a little bit of light bleeding onto the moon. So it's not black like a total solar eclipse. Partial looks the same, only a part of the moon is covered in that shadow for a brief period of time. And then the final one, the final type of lunar eclipse, is called a penumbral. And this is almost like a part of a shadow. So you've got a partial shadow going across the moon. And this one's a little weird because the area that gets covered, it just dims a little bit. Not completely dark like a partial lunar eclipse, but just a little dimming of an area for a few hours as the moon goes into this weird shadowy area, which blocks a little bit of the sun's light. All right, I hope this helps, and let me know if you have questions.